Okay, Math 95, this is Professor Sue, and I've had a request to do some homework problems from section 8.2. And 8.2 is systems of equations using the substitution method. So just to refresh, from 8.1 you learned that systems of equations are two linear equations, and we want to solve them. And there's three things that can happen. I'll say solve them and see what happens. Okay, so three things can happen. And you might have already gone over this in 8.1. I'm just going to review. We can have one solution that's where the two linear equations intersect in one point. I'll say meet up in one point. Okay, we can have no solution, and that's where the two lines don't meet up at all, or the two linear equations have nothing in common. They don't meet up. So we've got one solution where the linear equations have one point in common. They meet up in one point if they're the two lines. We've got no solution. The two linear equations do not meet up at all. They have no points in common. And then we've got infinitely many and that's where you've got infinitely many answers. So the two linear equations meet up everywhere. Sorry. So that's one solution, no solution, infinitely many. And that's what they're going to ask you on the homework. So I'm going to do one of each. I did the homework on Hawks and I picked out three problems. So I'm going to try and make it a little bit easier. But here's what we're looking for. One solution, seeing if they meet up in one point. No solution, they don't meet up anywhere. Or infinitely many, they meet up everywhere. And I'll show you what that looks like. Okay. So, like I said, these are Hawks homework problems. So here's the first one. It'll say solve the systems of equations. And here's one of the very first ones that Hawks gave me. Okay, so the first thing I like to do is I like to look at both of these and see, do they have anything in common that I could divide out and make them easier to work with. So what I'm seeing here is, I see that this top one, 3 goes into all of them. So I'm going to divide that top one by 3, each one by 3, and I'm going to get negative 3x so I just divided each one of these by 3. And then this one, I have 2 negative 2's and a positive 2. I'm going to divide everything by negative 2 since I've got more negative 2's. Now, sometimes you won't have a number that you can divide out of all of them, but sometimes you can, and it's easier. I don't know if she showed that at all, but it seems easier to do for me. So this is x 2 divided by negative 2 is negative 1y. Okay, so isn't this easier to work with than this? Now here's where substitution comes in. So I want to look for one variable that's sitting alone and preferably doesn't have a negative in front of it. That makes it a little bit harder. So we could, I see here that I've got a y sitting alone and I've got an x sitting alone. So you pick either one, it doesn't matter. So a lot of times people in my class like to solve for y. I don't know why, they just like to, they just like to do that. So it's easier to solve if he's by himself. Let me write that on here. I'm just giving you little tricks of the trade, okay? So I'm going to pick the first equation and I want to solve for y. And like I said, I think it's really easier to solve for x, but a lot of people, I mean, and I've been teaching for a long time, I think most of my classes go for solving for y. I don't know why, but they do. So we're going to solve for y. So I want to get y by itself. How do I get rid of this negative 3x? I add the opposite, right? Okay. Can I put 9 plus 3x together? Are they like terms? Heck no. So y equals 9 plus 3x, or you could say, I'm going to put the x first, y equals 3x plus 9. Okay. Okay, here's where the substitution comes in. Now we're going to substitute sorry about that. We're going to substitute okay, so I know y equals 3x plus 9. My other equation was x minus y equals 1. So I'm going to take 3x plus 9 and I'm going to plug it in here. And notice there's a negative in front. So I want to put parentheses around that 3x plus 9. So this is why it's called substitution, because we're taking and we're substituting. Since y equals 3x plus 9, I can take that and sub that in for y. And because there's a negative, I'm going to put a parentheses around it. And if you need to, you can put a -1 here if that's easier for you, and then distribute that. So I'm going to distribute this, and I get x minus 3x. -1 times +9 is -9. So again, I just distributed that. I'm getting there. So you know there's an implied 1 here. What's 1x minus 2x? Well, that's -2x. I'm just showing all my steps for people that need it. Now I want to solve for x. How do I get rid of -9? I'm going to add 9 to both sides. So these go. And last step is always division. I'm going to divide both sides by -2. So I know my x is -5. So I'm not done, because this answer is a point, and I need to find the y part. So this is looking like this is one solution. So this is 1 point, and I need the x part and the y part. So some people forget to find the y part. They just give me the x. So make sure you give me the x and the y, and written as a point in parentheses. So we can take and plug in the y into either equation. Oops, I'm sorry. We can take the x and plug it in. So you know what? I'm going to take and it doesn't matter whichever one you want to do. I'm going to take this. This was my first equation, and I know x is -5, so I'm going to plug that right in there and get my answer. So let's see what y is. 3 times -5 plus 9, which is -15, plus 9, which is -6. So here is my final answer written as a point. So my answer is, you're going to click on one solution, and they're going to give you a box, and you're going to put in the point -5, -6. X was -5, y is -6. So those two lines, or two linear equations, they meet up in one point, -5, -6. And if you want to do a check, you can go back and for both equations, plug in x and y, and they should both come out to be correct. Okay, in the next video, I'm going to do an example of no solution and infinitely many.